Okay, so if we take a look at this problem, let's remind you what this means. This notation means if I put -3 into G and get that answer, I will put that answer into F. So you want to think about writing it like that. Okay. If I put -3 into G, I get the square root of 9 minus, minus -3 squared. Now I still have to put that into F. I am so sorry, my writing's just, anyway, so -3, when I square it, that's going to become a 9. So it's going to be the square root of 9 minus 9. That's the thing we're plugging in. And so the square root of 9 minus 9 is the square root of 0, or 0. Now, once you go to the point where you're ready, you have a value, now plug it in, and so we get 1 over 0, which is an undefined value. So the one we're looking for is that one right there, okay? So the answer would be D, okay? Remember that from last year, that composition of functions. So in this lesson, our objective is to think about graphing, transforming, and parent functions. Okay, so we just want to really be working on what a function is. We will be talking about like the vertical line test, what is a function composition, how to work with functions. And function notation. Okay. So really, chapter 1 is going to be a nice review of what we know about functions in general. There are 2 books I'm probably going to share with you, although most of the time your homework is not going to necessarily be in the book like it was in prior years. It is going to be directly in the note sheet. So this is the book that I might sometimes use. So that OpenStax is an Eastern Gateway book for those of you that are going to be taking it for Eastern Gateway. This one I've used in the past with YSU. I like it better, so we may at times be focused on that. I'll probably give you a PDF copy of both books. They're huge and giant PDFs, so I would probably put them into Notability or even the Books app, you know, that orangish app, so that you have it. But I'll let you know when I care about it. Okay, so let's look at some definitions that we need. So function, remember, every x is paired with exactly 1y. Every x is paired up with exactly 1y. So that's what I would think of there. Remember that x, the set of x's, is going to be our domain. Usually I'll abbreviate it just a capital D, and the y's are the range. I do, but let me finish recording this, and then once I am done, I'll yell at you. Remember, the independent variable is what you're plugging in. Usually that's going to be your set of x's. The dependent variable, what I get, depends upon what variable I stick in. So that's why y is the independent variable. It's what you get out. So it's usually the set of y's. So the independent variable usually goes with the domain. The dependent variable goes with your range. You want to think of a function like a machine. I have an x, I put it in my function, I get out an f of x. You may recall last year I drew my beautiful little conveyor belt. Okay, here's my machine. There's my F machine. The conveyor belt is sticking in x's, and when it comes out, it has been made into an f of x. So we can think about it like cookie dough is our x's, the oven is our machine. When I stick the cookie dough in, it's no longer cookie dough, it becomes cookies. So the x is our independent variable. What kind of cookie dough did I put in? If I put in chocolate chip cookie dough, I bet you I'll get chocolate chip cookies. If I put in oatmeal raisin cookie dough, I'm going to get oatmeal raisin cookies. So you want to think of the independent variable as the thing you put in. The dependent variable is what do I get out based upon what I put in. Okay. Remember, for function notation, xy is the same as x f of x. It doesn't have to be f. That's the most common function because it begins with an f and function. You know, they might call it f of x, g of x, h of x, whatever. And then finally, our last definition here is what does the vertical line test tell us? If a vertical line, if any vertical line, only hits the function or only hits the relation once, then it's a function. If any vertical line only hits the relation once, then it's considered a function. Now, all this stuff is review. It shouldn't be anything exceptional or out of the ordinary. So that should be something that hopefully you just remember the terminology. We did talk briefly last year about horizontal line tests. Horizontal line tests are only really going to come up when we talk about inverse functions, when we talk about whether or not we need to have a one-to-one function. So I'll remind you of that when the time comes. Any questions about the definitions or anything you see there? Okay. There are 4 ways to represent a function. We can represent it in xy pairs. That's one way. We can use our f of x notation. We can use our y notation, and we can use a graph. Now, the one thing you're going to notice that's going to be a little different than our pre-calc class is that you're going to notice that we will sometimes be given information about this f function that we know nothing about. We might not know what the algebra is. We might not know the graph. Or we might be given a graph but no algebra that matches it. So it's going to be possibly a little more abstract, but that's okay. I think you guys can handle that. You guys, I don't think you'll have any problems with that. And you'll see when I show you some examples what I mean by that. Remember, the domain is what X's work. And there's two main type of domains that you really have to remember about. The first domain is going to be square roots. What messes up a square root? Well, the inside, so whatever's inside, the inside has to be greater than or equal to 0. So many of the functions we're going to deal with are going to have domains of all real numbers. I can put in whatever works. But square roots, we might have some issues with, okay? The other type of function that can be a little bit ooky for domains, my math word ooky, would be fractions. For a fraction, just remember that the denominator is not allowed to be equal to 0. So if you remember those two things when asked to find domain, hey, it's a square root, I should worry about what's inside. Hey, it's a fraction, I should worry about the denominator. If you just remember those two facts, the rest of denominator stuff, the rest of domain stuff should fall into play. Range, remember, it is the output, the y's, the result. What do you get? So range, most of the time for this course, we're going to have to look at the graph. So the graph is going to tell us that. And the graph, we're specifically looking at how it stretches from bottom to top. We're really pretty much asking ourselves, how does it stretch from bottom to top? And again, these are things that we extensively went over last year. Chapter 1 should be mostly review with a little bit of push up to the next level of math. Everybody good with that stuff? Okay. So we have this graph here, okay? Now let's assume the graph, all the graph is there. Those are not arrows on the end. The graph stops here and stops there. And let's assume it hits that point. Let's assume my graph connects nicely and looks perfectly like that. Let's assume that. I did my best at the time when I created this. Okay, so if we want this graph, so this is our graph of f. If we want the graph and it says, what is f of 1? Remember what we're going to do. F of 1 is the height when x equals 1. It is the height when x equals 1. So when we go over to our graph, here is an x value of 1. The height is that point right there. So what is our height when x equals 1? -3. So we can say that f of 1 equals -3. So we don't necessarily have an algebraic representation of what that is. The graph is going to give you that answer. We didn't do that as much last year. Let's find f of 5. So again, we're going to go over to the graph. 1, 2, 3, 4, 5. What's the height? And then let's assume it hits 1 exactly. So that shouldn't be anything magical to you, okay? Now, let's talk about domain and range. Unless the instructions say otherwise, I want domain and range in interval notation. You might recall interval notation says, what x do I start with? What x do I finish with for domain? What y do I start with? What y do I finish with? It is always in least to greatest order. Brackets mean I landed on that spot. Open circle means that I did not. Let's assume that graph is all connected. The domain are the x's I start and to the x I stop. If you count 1, 2, 3, 4, 5, 6, 7, I am starting at -7, and let's assume there's not a perfect open circle there, that I am there. 1, 2, 3, 4, 5, 6, +7. So I would say that my domain would be -7 to +7. And that implies that I did not skip any values from there to there. That implies that I am at every value in between. Okay? Now let's talk about range. Range is your lowest value to your highest value. It appears as if my lowest value is -3. Assume those points connected right there. And then I have all the y values until here. Now, y values, you may have to look from left to right to figure out where the y values are. Did we skip any y values from here up to there? No, we did not. And we assume if those are closed in dots, that our lowest value was -3, and that our highest value was +3. So remember, domain goes from left to right and includes everything that you have touched along the way. Range goes from bottom to top. Where do we start at the bottom? Where do we start? Is there anything in between? You might have to look left to right because some things might not show up in one place, but if they show up in the other, you're good to go. Everybody good with our first example? So I would like interval notation unless the instructions say differently. Okay. Let's look at these examples. Let's talk about how we graph some of these things, okay? Let me remind you, well, first, okay, A, what kind of graph is that? Is it, think about all our graphs we've learned, linear, absolute value, reciprocal, parabola, cubic. What is it? What is A? Yeah, it's just a linear equation, right? Please don't make these harder than you have to. You know, they're y equals 2x minus 3. It has a slope of 2 and a y-intercept of -3. You can graph a line as long as you have 2 points. You may graph whatever, however you want to. I do not care. But let's go ahead and graph it. We're going to start at -3. We're going to go up 2 over 1, up 2 over 1. I can't make very good straight lines, so I'm going to stretch that graph out. Please make arrows, okay, to imply that that graph does not stop. You'll notice if I did not put an arrow like that last one, I did not have arrows on the ends, then you can assume it stops unless it's very clear that the graph paper ended and it's going to still go. So let's talk about domain and range for this function. The domain. Did we skip any x from left to right? Is there any x that we cannot plug into a linear function? No. So what's the domain? -infinity to +infinity. Range, how low does this go? How low does this graph go? -infinity, right? How high does this graph go? +infinity. Did we skip any in between? No. So the range is -infinity to +infinity. This second function, when it kind of formatted, it should say g of x equals x squared plus 1. You kind of get the idea that that's what it means. Let me remind you how to graph a parabola. There's a few different things you can think of for this one. Isn't this a parabola that's been moved up one? So if you know the general form of a parabola, you can just move it up one. You can also remember that the vertex of a parabola is -b over 2a. Once you know the vertex, you can just plug in a point at the vertex, plug in an x to the left of it, plug in an x to the right of it. You'll get the symmetry of a parabola. I should not have to tell you at this point when you're sitting in calculus how to graph a parabola. You got to know -b over 2a. I'm going to assume you know how to graph a parabola. No, it's kind of, shut up. Okay, so, so anyway, The vertex happens at 0. And then if you move both of the points at 1 and -1 up 1, you got your parabola. We can even go 2 to the left and 2 to the right are 4 up from our vertex. Whichever you do it, just please make sure you review if you've forgotten how to graph a parabola. It is important that you know it. The vertex of this parabola was 0, 1. So if you know that, you can just move your parabola. Now let's talk about domain and range. The domain of a parabola, is there any value that you're restricted to plug in? No. You could think of this, this U shape, this parabola shape, will widen and widen and widen for the rest of existence. So if we think about the x's, how far left can it go? I could plug in -100 million, and it's a value. Giant, high up, but it's a value. I could plug in on the opposite end +100 million, and it's still a value. So the domain is all real numbers. Remember, polynomials, the domain is always all real numbers. Now the range, depends on what it looks like. This range, what's the lowest point for this parabola? 1, right? I can land on 1, right? So that's why we put a bracket on it, because we can stand on that one. I always think I can stand on that point, and then I can go forever as high as I want. Infinities always get a parenthesis, okay? Infinities, remember, always get a parenthesis. For negative infinity to positive infinity, if you want to use the all real number symbol, so range is 1, just a normal capital R. All real numbers should be more of a fancy R. That's so gross. Let's put it over here. Should be more of a fancy R with kind of like a double back to it. That means all real numbers in a calculus class. Okay? Everybody got that? Any questions on what we see there? Okay. So let's look at some examples. We're going to do, I'm sorry, the highlight looks so weird, but we're going to do these 3 on this page, and then we'll do this one because there's not enough room. So let's do these 3 first, and then we'll go to the next page and we'll do that one. Okay, so first let's start out with f of -a. So remember, we are taking out the the x, and replacing it with -a. We're taking out the x, we're replacing it with -a. Parentheses, 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 because it will allow you to catch anything that needs to switch sign. So when I square a negative, I get a positive. So that's going to become a positive a squared. Here, our 2 negatives are going to make a positive, and then we have +2. We can't go further. We don't know what that is. It is what it is. Just leave it. Any questions about f of -a? Now, one that's a little more difficult is f of x + 1. When we take out the x and we put in x + 1, when we take out the x and put in x + 1, parentheses, 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 you have to remember that x + 1 squared is x + 1 times x + 1. You can't just square the pieces. That is an algebra 1 mistake. If you don't know that x + 1 squared is x + 1 times x + 1 and do it correctly, you have to rethink your decision to take calculus. I'm sorry, I'm just going to be honest. What is x + 1 squared? Oh, I sure did. So you have to be very careful when you do this. You can make mistakes like I do, but please know what x plus 1 squared is. That's going to be x squared plus 2x plus 1. If you square it and just try to square the pieces, you're going to miss that 2x and you're going to get it wrong every single time. The rule is that a plus b squared is always a squared plus 2ab plus b squared. You know that formula for the difference of squares, a squared minus b squared is a plus b and a minus b? That's something you guys always seem to remember, but you don't always remember that. You do tend to forget this 2ab in the middle. So be careful, please. Okay, now going back to our problem. So this is going to be 3 times the quantity of x squared plus 2x plus 1. I'll distribute everything here in a minute. And now let's distribute all of the coefficients, which is 3x squared plus 6x plus 3 minus 5x minus 5 plus 2. And then combine like terms and be done with it. So our final answer would be 3x squared plus x and then plus 0. So it's just 3x squared plus x. Any questions about what we have there so far? Okay, now let's do f of a squared. Now, first off, let's just think about f of a. F of a is just 3a squared minus 5a plus 2. No, I think we're good. 3a squared minus 5a plus 2. When you square it, and there is a square outside of the function notation, you have to put the entire thing in parentheses and square it. Okay? So it is the entire thing squared. You're good. Now, remember what that means. That's 3a squared minus 5a plus 2 times 3a squared minus 5a plus 2. Now, so that it doesn't take me a million years to do this, think about what you're going to do. 3a squared times 3a squared, 3a squared times 5a, 3a squared times 2. And then you're going to distribute the negative 5a. And then you're going to distribute the 2. Okay? So you're going to get a long, long list. Okay? You're going to get 9a to the 4th minus 15a to the 3rd plus 6a squared minus 15a to the 3rd plus 25a squared minus 10a plus 6a squared minus 10a plus 4. And then when we combine like terms, you get 9a to the 4th minus 30a cubed minus 3a squared minus 20a plus 4. Okay, so this course requires you to be careful with your algebra. It's easy to make little mistakes. Did I make a little mistake? Okay, let's see. Okay, let's do it again. Okay, 6 plus 25 is 31. Plus 6 is not 3, but it could just be because I can't see what that says. It is not 3. What is it? 6 plus 25 is 31 plus, and where did I get negative in the whole? I don't know. I was just checking. Yeah, are you paying attention? But is the A's right? Yeah, the A's are okay. Everything else is okay. Okay, so that should be 31a squared. Thanks. 37, my God. You didn't have the other 6. Listen, I've had a rough weekend. I did not have power till yesterday. I didn't have it since Thursday night, and then at midnight it went out. I've had a rough weekend. My brain isn't functioning. I haven't slept good. Oh, okay. So now let's talk about this piece here. So the last one we have to do is that one. Okay. So now I've made a whole nother page for it because it just takes so much room. Okay. Now we're going to focus on this. This thing here is called the difference quotient. When we learn something called the definition of the derivative later on, I think maybe in the beginning of chapter 3, maybe the end of 2, when we learn that definition, that is some algebra that we're going to have to know how to mess with. So I wanted to show it to you now so that we can play with it a little bit. Okay. So when I do the difference quotient, do you see, let me write it over here. The first thing I do, and I do it kind of independently on its own, is I figure out what the heck is f of a plus h. So that's algebraically the most difficult part. So let's do f of a plus h over here. So we're going to take 3. We're going to plug in a plus h for the x. In parentheses, we're going to plug in a plus h over here. And then plus 2. Okay. So this looks very much like the one we saw over here when we plugged in x plus 1. Same procedure, except we have an a and an h now. Okay. So we're going to get 3 times the quantity of a squared plus 2ah plus h squared. I'm just going to keep the 5 there, and I'll distribute all at once. Okay, so let's distribute, then combine like terms. Let's get everything pretty. So we get 3a squared plus 6ah plus 3h squared minus 5a minus 5h plus 2. Now let's think about what things are alike. There's no other a's squareds. There's no other h's. There's nothing alike, is there? No, there's nothing we can do. Okay. So this has to go in that spot. So let's rewrite that over here. So that's going to be 3a squared plus 6ah plus 3h squared minus 5a minus 5h plus 2. Next, we are going to subtract. We're going to put in parentheses what f of a is. Now, f of a is not a difficult task. All we're going to do is take the a and place it where the x's are sitting, but put it in parentheses. So f of a is just going to be 3a squared minus 5a plus 2, and then it all goes over h. Now, when we're all said and done, you have to get to the point where the h can divide into the top. If at the final step the h can't divide into the top, something is wrong. Okay, so let's go over what I did. F of a plus h went here. Okay. F of a is here. Just take out the x's, put in a's. And then it's all over h. Okay, does everybody see where I'm at this point? Okay, so next, distribute. You're going to call me probably. So when we distribute, so that first piece, and you know me, I make stupid little mistakes. You have to be so careful because it's so easy to make a little mistake. Okay, at this point, we need to make the top as pretty as possible, just reduce it down, okay? So let's go through the list. Everything that does not contain an H at this point should cancel out. Sometimes the H's do, but at this point, everything that doesn't contain an H should cancel out. So 3a squared doesn't have an H. Guess what? There's a negative 3a squared over there down the line. Negative 5a and positive 5a cancel out. You need to stop. Positive 2 and negative 2 cancels out. Here's the way to check that you're probably on the right track for getting the correct answer. Does every single piece that I have not highlighted contain an H? That's a great sign. Probably our algebra is right, okay? So we're going to take 6AH plus 3H squared minus 5H, and you should at this point be able to divide every single piece by H. Now, I'll tell you, this is a key to check you're right or wrong. What we're doing eventually with this difference quotient, we need the H to go away. So if the H doesn't go away, check your work, you did something wrong, okay? So now you have to divide. That H is on the bottom, it's under everything, so we have to divide it into everything. Our final answer would be 6a plus 3h minus 5. Are we good there? Make sense? Okay. We are going to stop where we're at right here. We will continue these notes tomorrow. If you would like to go to the 1-1 homework and start that tonight to take a look at what that is, we will continue our notes tomorrow. Now, my goal was to get through 1-1 and possibly 1-2. Our week is so short, who knows? So I might adjust some timelines, but start your 1-1 homework tonight. I'm going to Zoom, that's for sure.